recording this computer. Okay, what I'm hoping you can see with this, I hate to see anybody have to do more work than you need to, right? So when they give you a polynomial, it's all expanded out like this one. All we really interested for this is what's the degree. The reason we want to know the degree is what's the ending behavior, right? And then the leading coefficient, we want to know if that leading coefficient is positive or negative, because that means there's a reflection around the x-axis, right? So we could FOIL it all out, expand it all out, but all we really need to worry about is, I mean, if you think about this, right? I've got, if I multiply out 3x plus 1 times x plus 1, I'm going to get 3x squared plus a lot of other terms, right? So I've got that 3x squared plus a bunch of other stuff times 4x plus 3. So if I do this next multiplication, isn't this 12x cubed going to be the leading coefficient, the leading term? There's no other x cubes in this whole expression. So don't bother taking the time to expand it all out. Just do the 3x times x times 4x, and you'll get the degree and the leading coefficient. So the degree is 3 and the leading coefficient is 12. It's positive. So that tells me, I mean, this isn't asking you this question, but well, what's the long run behavior? Well, as x, because it's just a normal everyday x cubed function, not been reflected around the y-axis or x-axis. As x goes out to negative infinity, y goes out to negative infinity, because remember, these cubic functions always look like this. Yes, this is growing faster because of the 12, but it's still headed out that way. And then as x goes out to positive infinity, y goes out to positive infinity. Okay, just like here. I mean, if we do expand those out, what's the leading coefficient? Well, a leading term is going to be 2 times x times 3x. So that's going to be what? 6x to the third. So degree is 3, leading coefficient is 6, without having to expand that all out. Okay, so I hope you see that. See, there are a couple more problems here I could do, because I'm going to ask you this. Well, that's going to be, let's look at number 34. That's worth doing. Or maybe even G. I know they're asking for the intercepts. They aren't asking this. But what's the leading term? What's the leading coefficient? So I know I'm going to get 6n squared, and that's getting multiplied by the -2 out in front. So negative 12n squared. So the degree is 2, but it's going to be reflected around the x-axis, right? Because of the negative. This one would be, let's see, negative n times 4n. I know that's where the leading coefficient is going to come from, or leading term is going to come from. So negative 4n squared, and then that gets multiplied by the -3. So that's 12n squared. So leading term is 12n squared. The degree is 2. The leading coefficient is 12, right? Yeah, I mean, you can do a lot of the other ones. Well, I mean, what about this one? What if we have x squared plus 4 times x to the 7th minus 2x plus 7. I'm not making this up. And x plus 3. What's the leading term? What's the degree of this polynomial? What's the ending behavior? You can stop it and think about it. Or if you didn't stop it and you lost, I'm just going to worry about the x squared, the x to the 7th, and the x to the 1st. I'm getting x to the 10th. Remember, you add 2 plus 7 plus 1. And so that's the leading coefficient. It's the leading term. It's 1x to the 10th. What's the ending behavior? It'll be, well, let's see, it's an even degree. So that tells me it's going to look like this. So as x goes out to negative infinity, y goes out to positive infinity. And as x goes out to positive infinity, y goes out to positive infinity. Okay, so I hope this helps. Hope this saves you some time. That's what I'm trying to do.